Everyone. Welcome to another meetup from Fabric Power BI Portugal. This time we are returning to a recurrent subject that is DAX. I think there is a love-hate connection with DAX, but we need it for our Power BI. So in this meetup we have Markus. Thank you for joining us, and will give us some things about what we need to know when we're learning DAX. This is always useful because I think we are always learning DAX. So even this week I learned a new thing that I didn't know were possible. So although I've been working with DAX for 8 years, welcome Markus, and please make your introduction and let's start the presentation, okay?
Thank you, Miguel.
Just one thing, sorry, Markus. If you have any questions, please put them on the chat, and then we can answer them as we go along. Or if there is any breaks in between the presentation, then you can just speak. Okay, thank you.
Yeah, it's also okay for me. The language for this talk will be in English because I don't speak any Portuguese. The only thing I can say is hola. If there's any questions, feel free to interrupt me. So unmute yourself, turn on your video or not, and just interrupt me. I should be fine with that. Usually I'm not losing my track. And I will share my screen, right? This will help with all the demos and everything, most probably. So give me a short sign if you can see my screen now. Now Teams disappeared again. Where is my Teams window? I love Teams. This is the video. Yeah, so I can see you again and I can see the chat. Okay, so 5 things you need to know when learning DAX. This is like I wished for that somebody told me when I started learning DAX. So it's more or less, it's introduction to DAX. It's a beginner session. But maybe it helps you also to rethink some of the concepts you have in your mind. Yeah, let's see where we're going there. So mouse cursor here. And so the important things, the 5 things, so I put 5 things because like one hand has 5 fingers, right? And 5 things are easy to remember. And I have 60 minutes, so I can explain 5 things by using like a little bit more than 10 minutes to explain things. So this should work out, right? This is the idea of this talk. So the first thing is that calculated columns, they behave like Excel formulas. And this is the easy part in DAX because many people I know, they know Excel formulas way better than I. So I know only a bit of Excel, but many of my customers, they're like wizards in Excel. They use VLOOKUP. I cannot write VLOOKUP, right? But they feel at home when they see DAX because the syntax is very similar. On the other hand, there is also measures. And measures are different, and measures are filtered. We'll come to this back again when we come to this point in the agenda. And measures can behave like Excel formulas. So usually Excel measures do not behave like Excel formulas. They behave differently. We have to use aggregation functions and things like this. The other thing which is very interesting is if you think about it, that the DAX author, so you, when you write a measure, you have control over the filters which are applied to a calculation. That means that you can write a measure which makes some of your products disappear or things like that. So only things with a value are shown, right? So if you filter things out, then maybe a product or year or something is not shown because you have control of the filters in your DAX measure. And the last thing is, that's like summing up everything you need to know about DAX is that calculated columns and measures, they share the same language. So both are written in DAX, but from a concept perspective, they are different things. So this is one of the mistakes you can make, that you think columns and measures are similar. No, they are not, if you ask me. So the earlier you accept that there are 2 different things, the easier your life will be when you need to write calculated columns or calculated measures. So let's start with calculated columns behave like Excel formulas. So what is DAX? DAX is data analysis expressions, sometimes also called data analytic expressions in the beginnings. They were born with Excel, right? There was an Excel add-in. I'm not sure if anybody of you can remember that there was somehow an Excel version 2010. And for this version, you could download an add-in. Was free of charge, but you had to download and install it on your machine, which made it difficult for many people because they're not allowed to download anything or install anything on their machine. With Excel 2013, this Power Pivot add-in was part of the Excel product, and later then the product behind the team behind Power BI discovered, Excel, they deliver like every 3 years they deliver something. Now they are faster because they're also in the cloud, right? But 2010, 2013 was the next release, so they decided to write a tool called Power BI Desktop. This was like the successor of this add-in. Power BI for Excel is still there, but now with Power BI Desktop, the product team can release every month without having to wait for the Office team, because like inside of Microsoft, this is completely different teams. The Office team and the data and analytic teams, this is two different. They are funded differently. This is like two different organizations, two different companies within Microsoft. And also the analysis services Tabula uses also the same storage engine. So behind Power Pivot for Excel, Power BI service, Power BI desktop, analysis services on your machine, like SQL Server analysis services or Azure analysis services. All of those are just different tastes of the same thing, of the VertiPack engine. The VertiPack engine is an analytic database. So if you start Power BI Desktop and start loading things into it, and then import data into Power BI Desktop, and then you open up the task manager and you look for the task within Power BI Desktop, you will see that there's a SQL Server Analysis Services process running within Power BI Desktop. So that's the same thing, the VertiPack engine. And this database does not understand SQL like many databases, maybe the relational databases, but this database understands DAX. So this is why DAX is so important, because that's the language we talk to this special analytic database. As DAX was born after SQL and Excel and MDX, of course, people were smart enough to take the best of breed, right? They looked up what's cool concepts in Excel, for example, the function-based syntax. Everything is a function in Excel and also in DAX. I was told I cannot like prove it because I don't have access to the source code, but I was told that over 100 functions have even the same source code. So if they change something in Excel, it would also change how the DAX function would behave, because it's the same thing, literally the same thing. From SQL, I'm not sure what's your background, if you ever wrote a SQL statement, like a select statement or update or something. And from these concepts, the relational functions were taken. Relational functions are not very used very often in DAX. We have some of those functions. We will not talk about this in this 60 minutes, but there are some functions there. Usually they're not necessary, but the concept is still there, and there's something called a row context. The row context is what I say that like DAX behaves like Excel. That's the row context, that you define some formula for a column, and this formula is then evaluated for every row in your result set, for every row in your table. So one formula, and then executed like 8 times because there's 8 rows, or 8 million times because there's 8 million rows in your table. That's the row context. In SQL, doesn't really have a name because there's no other context. There's only the row context. From MDX, which is the multi-dimensional expressions, which is the language of the other analysis services, right? Maybe you heard about cubes. Cubes were really big and huge for over 20 years, right? 25 years. And then the tabular system came up. But there's also analysis services multi-dimensional, which are they called now, because in older times there was only analysis services. Nobody talked about analysis services multidimensional because there was no other analysis services. But since Tabula, we talk about multidimensional analysis services, multidimensional. There's no service in the cloud, so there's no multidimensional analysis services Azure version of it. It's not used inside of Power BI desktop. It's not used inside of Power BI service, but it's still there. There's many systems using this. It's still patched, so there's no security issues with databases like this, but it's not further developed because all the investment from Microsoft goes into the Hubble engine. But still, there's databases are there, and also the concepts are really smart. There's a concept of measures, so having like a calculation which can be executed on top of a whole data model, so which can use aggregated values, where you can calculate things like time intelligence, where you calculate a year-to-date value, or where you can like calculate ratios, percentages, things like this. This is possible with measures. This is also taken from MDX, and this is also available in DAX. There's something like implicit joins, because usually a database is not just one single table. And if you build Power BI desktop files with only one single table, don't do this. This is worst practice. You should not do this. Usually you have several tables. And then the question is, if I take something from one table and another information from another table, how can I guarantee that like the combinations make sense? And this is what MDX and also Power BI and DAX just manages for you. So that I have to tell how they're connected in analysis services or in Power BI, and then the engine knows what to do. And there's a filter context. This is also known in MDX. That means that I have just one formula for this measure, but depending where I put it, for example, in the pivot table with different product over different years, right? Then I have the same measure, the same formula, which is executed several times within this pivot table, but the result is always a different one. It's the same measure, but the result is different because one is for the first product the first year, right? But in the second line, it's a different product for the same year. So the result is a different one. And maybe there's also a total column and a total row. And of course, those values also different. Same formula, but different filter context. What's new in DAX is this term context transition. So I can convert a row context into a filter context. This is not possible in SQL because there's no filter context. There's not an issue in MDX because there's no row context. There's only a thing because we have a row context and a filter context in Power BI in DAX. So we can also transition between those two. We will come to this later in this talk. And the good thing, but also the confusing part, is that DAX as a language is used for both measures and calculated columns. During the course of this talk, I hope I can point out the differences, that those two things are really different things. But DAX is also used for calculated tables, for row level security, and you can write queries. Usually people don't write queries, but what I do usually is that I manage some visualization in Power BI, right? Then look up for the performance analysis, and then I get the DAX value from there. And this is what then I use, for example, in DAX editor, or use in report builder if I have to build paginate reports on top of Power BI dataset, for example. Then I use this method. According to Alberto Ferrari, of course, I have also to cite and quote people like Alberto Ferrari and Marco Russo, those two Italians. They're the godfather. Godfather is wrong because they did not invent DAX, but they're very knowledgeable about DAX. They do nothing else than DAX for like 15 years now. So they're really, really experts. According to Alberto, DAX is easy, but it's really hard to learn in the sense that the semantic can be very complex. And if you begin your journey with DAX, this complex semantic can drive you crazy because you write things and you're sure you write everything correct, and then the numbers are just wrong. And you think the Vertipaq engine and DAX are just wrong. And then you discover, oh, there was like some concept you didn't think of. So sometimes it's really hard in the beginning. But the more and more you get used to this complex semantics, it will help you to write even complex measures, complex calculations, with a very short code. So this is like a good thing in the end, but in the beginning, it can be really, really hard. But coming back to Excel. So like 100 functions share the same source code, and the syntax in both is function-based. So I'm not sure if anybody of you also knows other languages, other programming languages. If in many languages it's not a function, right? It's a keyword, if and something, and then write then and something and else and something, and then you have to end the command or whatever. No, in Excel, as all of you, I suppose, know, it's a function, right? You have if functions, you have this parenthesis top on the end, and you have the first parameter, which is evaluated. If this evaluates to true, then the second parameter is returned. So if the amount is lower than 0, then blank is returned. In all the other cases, it might be wrong, it might be also blank or null, and then the third parameter is returned. So you only get the sales amount if the value is greater or equal than 0, right? And the syntax here is already not from Excel, but this is already from DAX, because in DAX we are not working with cells, as you can see here. So Excel has cell references, B3, A2, whatever, but DAX refers to a table, like the sales table, and within the table, I'm referring to the column amount. And we have to write these brackets for the column names. For the table names, I insist we should use the single quotes. So sometimes it's not necessary. For the sales table, it would not be necessary to have the single quotes. But if you have a table called date, for example, or product, there's also a function in DAX called date and product, then we need to write the single quotes. So instead of shifting and thinking about, do I need to write them or not, and having different codes, I try to do my best that I always write the single quotes here. But it's not mandatory in all the cases. Yeah, this is just a selection of those functions which are exactly the same. And yes, those are also functions. I mean, they look like operators, but like in the definition of the language of Excel and DAX, they're also functions, which are then called for you. Yeah, and all them I put like in bold font. Those are which I also use. The others not so much. So usually I don't have to use degrees or like have a cosinus or atanus or whatever. I don't do too much statistics, so I don't have to calculate the normal distribution of things like this. But yeah, many common functions are available in both in Excel. In the DAX and the work in DAX, they're very, very same. Right? And let's write something, right? Jump over to the demo. In the demo, I use a very, very simplistic data model. And I think this really helps. So if the data model is easy enough that you can like use your pen and paper to recalculate the things, it really helps you to evaluate if the calculation is right or wrong. If you have a data model with millions of rows, I mean, who knows if the number is right or wrong? So this is not a model view, it's just a report code model, and I just try to imitate the model view, but with the advantage that I also see the numbers here, so that the content of the tables. So I have a date table with the previous year and the current year up to the end of the current year. I have a product table with only 4 products, right? A, B, C, D with those IDs. And then I have a sales table, and the sales table only has 4 sales. So really easy. We can recalculate this even like in our minds. For the first of the month, I have 2 sales, one for the product A and another for the product B. On the second of the month, I only have something for the product B. So product B is sold 2 times. And on the third of the month, I have something for product C. Product D, unfortunately, was never sold in my demo here. I had to see the relationship. So there's a one-to-many relationship. Of course, this is not a really a relationship. It's just like a screenshot, an icon, a picture I put in here on this report to visualize how my things working here. What I want to build here is 3 different first calculated columns. So we will calculate a sales amount, which is the price times the quantity. We will calculate a margin based on the sales amount. When I subtract the total costs, I know what's left over from the sales amount. And I will also calculate the margin in percentage of the sales amount. That means like in percent, what can we keep, how many percent can we keep of the sales amount, right? So that's what's left over in percentage. Usually when I introduce or write calculated columns, I jump over to the data view, now it's called table view. This is already the October version. And I'm glad for that, because there were a version where this was the table view and this was the data view and this was the data section. And then it was really hard on the screen to explain where people have to look or click in courses. Now, okay, I'm positively surprised. This is the table view now. Okay, so I learned something today. Very good. And if we go over to let's go to the sales table here. So, and I can zoom in here, maybe not this way, but the other way. And then I create a new column. So new column here. Usually I right click and click new column. You could also come over here and click like new column here. But I think this is dangerous, because if I don't pay attention, then you maybe have the wrong table selected, and then you start over with a calculated column in the wrong table, and it will not really work. So you have to first choose the table, and as I'm already there choosing left clicking on the table, I also right click here and then choose new column instead of moving my mouse cursor over there again and choose new column. So that's how I use this new column usually here. And then we see this line here, column. It tells me column. So now I know I created the column, not a measure. I can also see that it tells me in columns tools up there. So this is also a hint. We're talking about columns. We can also see a new column here. And if I go back here, we see the special icon. So this is like a table where only one column is selected, right? And this is the sigma symbol. So this means this is a calculated column. Because as we start typing, so I want to create the sales amount, right? Now there's no text column anymore. So I have to rely on either that I remember or that I can see from different other perspectives that we're talking about a column. So the sales amount, by definition, is my price, which I have here, my price. And if I type in here, it should show me what's possible here. So the IntelliSense is really, really helpful. So it shows me all the functions starting or consisting of PRIC, but it also shows me the sales price, and I can just select it, right? Either I click with the mouse, or I can also use my the keyboard with the arrows and then select something here. And you should make use of IntelliSense. We'll later see situations where you start also referring something and IntelliSense does not show up and does not offer you what you're looking for. If this is the case, stop. Don't continue to write out your code because most probably there's something wrong in your thinking or whatever. Yeah, usually we can depend on IntelliSense, and if the IntelliSense doesn't show up the right things, maybe you need to rewrite your DAX expression in a different way. So price times quantity. So I type in quantity, and again, I can just select quantity from here. And with this table view, the good thing is we immediately see the result, right? So we have one formula, and it's a row context because we now have one formula, and this formula is executed for every single column here. So 3 times 10 is 30, 20 times 1 is 20, 30 times 4 is 120, and 100 times 5 is 500. Then we have another column. Right click here, new column. I can ask for, please calculate me the margin, and the margin is the sales amount here, minus the total costs, right? As easy as this. And then we can have a third one, as I want to calculate 3 different ones. And maybe also you get the idea, there's one calculation which does a multiplication, right? There was one with a subtraction, and the third one does a division. So we divide for the margin in percentage. I divide the margin with the sales amount. Margin with the sales amount. And we can write it this way. For reasons I don't have too much time to explain here, I prefer to write it with the function. So there's a divide function, which is not available in Excel, when I remember correctly. But this does all the error handling. So if there's something wrong, it doesn't really show an error, but it keeps your result empty, which is usually the thing we want to see. If the sales amount is 0, the margin in percentage should also be blank, right? There's no sense in showing an error message. So that's why I use the divide option here. And again, we should see the right numbers. Usually showing up as a decimal number, right? And we can just turn it to a percentage, format it differently. Then it will automatically multiply it with 100 and show it with a percentage sign at the very end. So this is what you usually want to see for percentage numbers. So jumping back to the slides and take a look if there's any question. Can these graded columns have conditional statements? Daniel, thank you very much for this question. Yes, you can write anything there. So I can write, for example, let's take my the margin percentage, for example. So if you're not using the divide function, we could, for example, write, and also can learn different other things. We can have Shift Enter to have a new line. Usually I recommend that you write like a long code, not wide code. So have one line per parameter, one line per function, roughly. And you can also comment things out. So if I don't like this, and I don't want to delete it with a // I can comment things out, and I can have multi-line comments with dislike, multi-line comments. Yeah. So, but the if function, yes, I can write, for example, if my sales amount is 0, then I know the division will not work, right? Because the division divides by sales amount, so this will be an error. So if I can write it like this: if the sales amount is 0, then I return a blank because I cannot calculate safely calculate my division. And all the other cases, I divide then the margin with my sales amount. So this would be one way. The reason why I'm showing this right now is because you did the question, right? The reason why I'm not using this formula is because the if statement tends to be slower than the divide statement. And one of the reasons is that we have to evaluate the sales amount 2 times, right? You have to look up the sales amount here and then here again. Maybe not so much when we're talking about calculated columns, but for measures, and especially if this is a more complicated expression, then I have to duplicate the expression on 2 different places in my DAX expression, which I don't like. And the other thing is, yeah, it had to evaluate it 2 times, so it will be slower. Does this answer your question, Daniel? Just let me know.
Yes, thank you.
Yeah, you're welcome. Okay, so I keep my divide here to continue with my demo as I usually do it. Then jump back to the demo, to the slides if there's no other questions. So calculated columns, usually when we refer to them, you should always mention the table name and the column name. That's a convention. Sometimes you could omit the table name, but I really recommend to do this so that we can see this is a column reference. For the measures, it's the other way around. You should omit the table name, so it's easier to grab that we're talking about the measure. Then the calculation, which is a little bit weird if you read it, right? It's a calculated column, but the calculated column is calculated row by row. This looks counterintuitive, but it makes sense, right? We have one formula for the column, and then it's evaluated and calculated for every single row in your table or in your expression. It's also really important to point out that the result is persisted in the data model. So this means that your data refresh will take longer because it will refresh the data from the data source or data sources, and then if after everything was loaded, it's re-evaluating every single calculated column. So the refresh will take longer, and it's persisted. So this means the memory footprint of your model will be bigger, and also if you save the PBX file, it will be bigger. So also opening the Power BI file will take more time because it has to load more data. So that's why I don't recommend to create calculated columns in first place. Always try to first write measures, and if this doesn't work, maybe a solution lies in adding calculated columns. But calculated columns should not be your first place. It's the first place in my demo and in my talk today because I think it's easy to understand. If you never have seen DAX, I think it's easy to see like the calculated column because you can easily see what's happening, right? So getting used to the syntax is easy with the calculated column. Calculated columns, they have a row context. That means that we can just refer to the price. And of course, it knows what the price is because it's evaluated row by row. So in one row, there's only one price column, so there can be only one price value. And the same applies for the quantity. So we just refer to the columns. That's the row context. And then we can use those. So if I put into these new columns or some of them in a report, jumping to the report view, and maybe use this one. And then I look up for my columns. So there's, for example, the sales amount, and maybe also use the date, right? We put in the date, and then we put in the sales amount, and then we put in the margin. So we see exactly the numbers we would expect, right? Remember, for the first of the month, it's those 2 rows. So it's 10 times 3, which is 30. 20 plus 1 times 1 is 20. 20 plus 30 is the 50 we're seeing here. On the second of the day, we have only one row, 30 times 4, 120, and the 5 times 100 on the third of the month is the 500. And then we can sum this up. So 500 plus 120 is 620 plus 50, 670. So this is the good thing with this easy model. We can understand what's happening there, and we can say, yes, this is correct, right? There's no mistake anywhere. If I also put the total the total cost here, we can also do the differences. So 50 minus the 40 is the 10, 120 minus 75 is the 45. This is also correct. And if I subtract 350 from 500, we get this 150. So this makes sense. Easy as that. The question now is why it's showing up the total down there. Of course, for us, it's intuitively, right? Because if I put something there, yes, the total makes sense. And the total is right. It's like summing up those values. in all the cases, which is also correct. That's what I would expect here. But it's why it's done, because we never wrote something that the result has to be added up, right? If you look, for example, for the margin, we told it we have to subtract things, right? It did not tell it that the margin has to be added up for the total or the sales for the sales amount. Sales amount doesn't even mention a minus or a plus. It only mentions this multiplication here, but still the value is summed up. And the reason for that is because there's some metadata information in the Power BI data model, which for the sales amount, for example, tells that there's a default summarization. Summarization it's now called, and the default value is sum. This is just chosen by Power BI. You can change it as you want to average, minimum, maximum count, or count distinct. So counts the rows, right? Count distinct looks up for duplicates, removes them, and counts only what's then left. Or you could also tell, do not summarize. Don't calculate anything. Don't show a total, right? This is called an implicit measure. So we define the calculated column, but behind the scenes, there's some meta information which is only used by Power BI, not by other tools. If you use Excel to connect to this data model, it will tell you, no, sales amount, I don't know how to calculate something there. You cannot put the sales amount into the values section of the pivot table because Excel does not know, it doesn't respect this setting here. This is only respected by Power BI itself. I'm not aware of any other tools which are respecting this. So this is another reason why maybe calculated columns are not really the solution for your problems, because you also want to offer people maybe that they can connect via Excel and then build pivot tables on top of your data model. So jumping back to the slides. So calculated columns, they have an implicit measure. So if you only have a calculated column, we still have this measure here. And I usually tend to have everything in orange if it's a calculated column, everything in blue if it's about a measure. And this is used about this summarization. Previously it was called default summarization. And we have this choices, right? And there's two sections, two different choices. One is for the modeling option. So you can choose for your data model, what's the default summarization, what's the default behavior. And for every visual, you can also change it. So you can have like the default summarization is sum, but in a certain visual, you need to show the minimum or the maximum. For some reason, I don't know, is that the count distinct and the count is like in different orders. And for the visuals, you can also choose standard deviation, variance, and median, which is not available in the data model. I don't know why. It doesn't really make sense to have two different options here. I guess it has been two different interns who worked on this UI. That's the only explanation I'm having here. And I don't know that they will like make it the same. They're always talking about that they will unify the user interface, but I don't know of any plans here also applied here. Now to the margin percentage, which I jumped over in the demo. So let's remove this total cost again. And I move in the margin percentage. Why did I take some time for the margin percent? Because, I mean, we can calculate it, maybe these numbers. If we look close, we'll see that this number is wrong. But if you think about the margin percentage, right? What is the margin percentage? That's what we, if we take the sales amount, subtract the cost and the margin, what's is left over, right? And the margin in percentage, what's left over in percent of the sales amount. So if you have a margin of 109%, this would be a very, very cool business running, right? Because that means that if our customers give us 100 euros, we can keep 109 euros of those 100, right? This is like magic, yeah. If you know how to build a business like this, please talk to me. I'm interested in doing huge investments in the business like this, but most probably it's not possible. There's some like recycling industries who like receive money if they take all the garbage, right? And then they burn it or like recycle it and sell it again. So they have like negative, what would you say, like negative costs. They earn money in receiving the goods, right? Which then sell further. But still, they have some overhead. So they cannot just make invent money out of nothing, right? So something is wrong here, obviously. Can anybody tell me what's wrong here? Why do we see this 109% here?
Markus, I won't tell you the answer because this is always the example I give on my class. that that this is the basic one why we shouldn't use calculated columns. But
and the default summarization, right?
Yeah.
Because the order of the operations are not mutable. You cannot change those. That's why.
You cannot change it. Yes, we can. We can make sure that we don't see the 109 there. The question is maybe also what was the right number? Yeah, what within right number? Maybe then we find out why we see what the 109 here.
Because you're doing the sum after the calculations, and you need to do the calculations to the items itself. That's what I mean by.
Yeah. Okay. Sorry. Yeah. Then I just did misunderstand you. So the margin in percentage calculates something, and the result of this calculation is then summed, right? That's what you're telling here, sum, right? So maybe you say, right, that's percentages, right? It doesn't make sense to sum up percentages. And of course, I could change it here. I could change it to, for example, say, no, this should not be a percentage, a sum, this should be the average, right? Then it's not 100%, so maybe it's right, maybe it's wrong, but what's the right number? Anybody knows what's the right number? What do I do to calculate the right number here? So if the margin in percentage is the margin divided by sales amount,
you can divide it 2005 to 7670.
Exactly. That's what you need to do, right? So I pull out the calculator. We also have an Excel form, but let's do it with the calculator. So 205 divided by 670, those two numbers, the margin, the sum of the margin divided by the sum of the sales amount, and this would be 30.6%. So 27 is close, but I would not dare to report it, right? I would not dare to put this report in production. So something is wrong here. And again, if you jump back to the slides, I think I have some explanation also there. Thank you very much, Joe. Okay, I don't have it in this measure, obviously. So what we need to do, and this is what this is coming up here. So what we need to do is we need to create measures. So measures are coming as a salvation for our problem here, especially for the percentages. So what we do in the measure is, when we refer to it, then we, I first do the demo, right? So jumping back again to my demo machine, and then I create, I want to create measures with the same name. So I'm not allowed to have two objects in the same table. So that's why I click here and ask for view the hidden. I have a hidden measure table here. So I put my measures in here. This is not necessary. You can put your measures either inside of your tables, or you can have a dedicated measure table. Doesn't really make any difference. The measures work the same, no matter in which table you put them. The only reason why we have to put a measure is because we need to find them over the UI. And the default with multidimensional, the default in Excel is that to have the measures always on top of the list, right? In Power BI, we have the full choice. We can put measures where we want them, and the syntax will be the same, the result will be the same. So if we again calculate the, let me start with the sales amount, right? The sales amount was like the price, remember? And if I type in the price in a measure, I'm in a measure because I've seen measure here, right? We also see measure up there, measure tools, and you see that there's a different icon here. But maybe also let's zoom in here. So we see measure tools up there. That's the sign that we now have a measure here in this formula bar. And also the icon here is like a calculator. It's the clear sign we're in the measure. And if I type price, it's not offering me the price column. And the reason is not because I created it in the measure table. Even if I would create this measure in the sales table, it will not offer the price column for me. Why? Because the measure is like something I have to put it in the table, but from the context, from the evaluation context, from how a measure works, it's like outside of the data model. It looks on the whole data model. And therefore, I need to specify what I need to do with the price, right? Because there's not just, there might be one price a column in my whole model, but there might be several rows with a price, right? We have 4 rows in our sales table, so 4 different prices. So if I just ask for price, DAX would not know what to do. Shall it sum up the price? Shall it divide it with something? Shall it count it? So in a measure, we always need to write an aggregation function. And in many cases, it will be, for example, the sum. If I write sum and now look up for the price, now I can choose the price column. That's what I meant previously. So if when the IntelliSense doesn't show up what you're looking for, maybe you have to rethink what they're currently doing. So sum the price and sum of quantity, and that's the same thing, right? And then I also create the calculate the measure for the margin. So the margin was this, like the sum of the sales amount, right, as written on the column here, minus the sum of the total costs. And last but not least, I define the margin in percentage, which made troubles as a calculated column, right? So this is like the sum of the margin divided by the sum of the sales amount, right? And again, I'm using like this just the simple syntax here. Usually I use the divide operator, but like having everything simple here, I use the divide operator here instead of the divide function. And if now I use this margin in percentage and move it here, then we should see at the very end that now we see the 36. So I have to also format it. Just press this format percentage here. Then the format changes, automatically multiplied by 100, and I get this percentage sign. And now we get the 36. So that's the right number. So measures can help here. If you need to divide something, if you do ratios, percentages, then you need to write a DAX measure. There's no way that you can do this with the calculated column. There's no way to prepare it in Power Query or in your data source. There's no way around DAX. So some situations you need to write DAX, and you need to write it as a DAX measure. Be very, very clear here. So I remove the wrong column here again, and then we see the right numbers. Again, back to slides here. So if I write a measure, if I refer to a measure, which we did not do currently, I omit the table name, because then I can move around the measures from one table to the other, and DAX can find it. If you also put the table name in front of the measure name, and then you redecide, you think, no, this measure table was not a good idea. Everybody is looking for this in the sales table. So I just move it into the sales table, which is rather easy, right? You can if I can find my virtual machine here, you can just take this and then tell it the home table should not be the measure table, but I move it down to the sales table. As easy as this. So now this margin appears in here. Yeah, for some reason it worked out because I called them margin in percent, the other one margin percent. So that's why it's working. And the result is still the same, right? So there's no difference. I can move those things around as I want. But if I'm referring to like measures margin in percent, then of course this formula will fail because it's not working anymore, because it's looking dedicated in the measure table. So if you refer to measures, omit the table name, then you're much flexibler in moving measures around. If you need to, if people ask you, because there's no right answer to the question, shall I put it in the measure table or in the sales table? The only person who knows the answer is the person who works with the data model. Where are they looking for your measures? Okay, back to slides. The cool thing with measures is that is again one formula, and the formula is then evaluated inside a context. So this means if I refer to the sum of sales amount, it's not always 670. It depends on the context. So if I have like again my pivot table with my products and my years, and then I put the sales amount there, the sales amount will be different in every line, in every column, in the totals, because it's evaluated multiple times. And every time it's evaluated, it's in a different filter context. One is for the first product and this year, and in the second line is a different product in the same year. So the evaluation is different. And there's always filters, right? So a measure barely shows an unfiltered result, because you always want to limit something to a certain year or to a certain product or to a certain market or whatever. Nobody's interested in like the overall sales amount over all the years and all the products. And the calculation is done when it's needed. So it's not saved in the data model. A measure is not persisted. You can add as many measures as you want, and the size of your Power BI file, the size of your memory footprint, the refresh time will not increase because it's just a formula. I mean, yes, it has to store the formula. So by a few bytes, the Power BI file will increase in size, but this is neglectable, right? And it's not persisted, so it means that it's dynamically created and calculated. So it's calculated as it's needed, and this means that whatever filter is applied is taken into account to calculate the result. So if we compare calculated columns and measures again, remember we have this row context in the calculated column, which means I can just refer to the price or quantity. And in the measure, we don't have this row context. So if I refer to the sales amount, this will not work because there's several values for the sales amount. So I have to put a calculation and aggregation function there. And cool thing is, does not mean it's always summing up the full sales amount from a sales table, but only for those rows available in the current filter context. It's not returning 670 all the times, but depending on what kind of filters I applied. Measures can behave like Excel formulas. Why would I need this? So a measure can behave like a calculated column. And this leads me again to the sales amount. I'm not sure if somebody did pay attention when I created the sales amount here, the measure sales amount. If I move it here, remember this was the column, right? So this was the right number. And maybe I remove the others and then we can compare those two. So I have two sales amounts. One sales amount, this one, the first one is the sum of sales amount of the sales table. That's the calculated column. The other one is the measure from the measures table up there, right? And as you can see here, there's like some of the numbers are the same, some of the numbers are wrong, differently, and those which are different are wrong on the measure side. So for one reason, we see 120 here, also for the first of the month instead of 50. Remember, it should be 50, right? Because on the first of month, we have two sales. 10 times 3 is 30, plus 20 times 1 is 50, right? Not 120. For the total, we see like a nice number. It would be great if we would have a sales amount of 2,000, but it's only 670. So again, what's the problem here? Can anybody tell me what's the problem with my calculation? I put up the formula here again. The sum of products is not equal to the product of sums. Yes. Exactly. So there's a difference in calculations. There's a precedence, right? I cannot just add things up and then multiply the results. That's different from multiplying things and then adding those up. And what we're currently doing with this sales amount measure here, so that's the measure what we're seeing here, is we are multiplying, or we're summing up the prices and multiplying with the sum of the quantity. And summing the quantity would be okay, but summing up a price is a really ridiculous thing to do. Like this is if you go to the supermarket, right, and you buy apples and you buy I don't know, oranges, and then you take the price of the apples, which is different from the price of oranges, and sum those two prices up, and then you count them out of fruits you're having, like 10 pieces of fruit, and you calculate those 10 pieces of fruit, multiply it by the added up price of both of the products. This is useless, right? This is a wrong number. So that's the problem here. So we're summing out the price and then multiplying the things. And this is different from multiplying things and then summing up the results, which is done here. So if we multiply things, the calculated column is a good thing because the number is right. But cool enough, we can also solve this problem here. So let's jump back to the slides. I think I have some explanation here. Yes, so that's the example which we're having here. So the first, third, and second and third, we have the same numbers here. And what we need to do actually is that we have to multiply the price with the quantity first. So 3 times 10 and so on to get these numbers, right? For the whole sales table, calculate those things. And in the end, we should not, or we're not allowed to sum up the price and sum up the quantity and again multiply those things. But in the end, we need to sum up those results. So we do 2 different calculations. First, we multiply, and then we sum up the results, as we did with the calculated column, right? And this is what the sum x function does for us. So sum x like iterator is what I'm used to say. So sum x is like the same thing like sum. So you can, if you have sum, you can write every sum also as a sum x. The sum x has two differences. First, it's two parameters. One is a table reference, the sales table, and the other one is expression. Sum only allows you to use a column reference, not an expression. And with sum x, you can have a full expression here. And this is what we're doing here. So we're first multiplying and then summing things up. And this is what we should also do in our demo, right? Because the other one was the wrong calculations. Jump back to the demo, and I'm seeing that I'm currently running out of time. There's so much things I want to show. So I need to write this like this. So I put in the sales, omitting the single quotes here, and then multiply the price with the quantity, right? So now within, this is still a measure, very important. We're still in a measure, but within this measure, we're creating something which behaves like a column, which has a row context. It's just referring to the price and quantity. How does it know what the price is? Because we ask it, please execute this for every single row in the sales table. So it's like writing a loop in another language. Yeah? You'll be looping over the sales table, and for every single row, we're evaluating this calculation. The result is then summed up. Yes, there's also a min x, which would return the smallest value. There's a product x, which was multiply the results. There's like 10, I think it's 10 different iterator functions. So we have like the row context in the calculated column. We have built the context in the measure, which allows us to use an aggregation function without having always the total, the full total of the table. But there's also a way of having a row context inside of a measure. So not as formal as the very same like we had in the calculated column, but this is inside the measure. So if you need to multiply things, most probably you need to reach out to sum x or an iterator function. If you need to divide things, you need to have a measure. You cannot safely do this in a calculated column. For subtractions or additions, not really make a difference, except for a calculated column is persisted in the data model and takes up more space. DAX author, we can also control filters, and to speed up things, because I have 5 minutes to go, I will omit the demos and keep with the slides, I guess. So what we can write is a measure definition. So this is blue, and this is this calculator here, and a raw sales amount, a referencing the sales amount, and then wrap it inside of a calculate function. And the calculate function was very mysterious to me in the beginning, because I thought, why would I write calculate? Of course, I want to calculate something. That's the whole meaning why I'm writing a DAX calculated column or DAX measure, because I want to calculate something. So why would I wrap something into the calculate function? But the calculate function is really, really powerful. Does two different things. One of the things we're talking here is that we can pass in further parameters and ask for it to change the filter context. So with this, we're asking for, please reset the filter context you're in and replace it with a filter. If there's a filter on the product description, replace it with a filter on A. So this, in this way, we get like 30 in all the rows, because like here is already A, right? And it's replaced by A again. That's why we see the 30 here. In this row, there would be a filter context on B. So the sales amount is 140, but this calculation replaces this B with A, and that's why we're also seeing the 30 here. A result like this is very meaningless, but what this opens up for is that we could, for example, have ratios. How much did B sale compared to product A? Then we can divide the sales amount by calculate sales amount product descriptions equals A. So this way we can like refer to different things in our data model. We can also remove filters. That means, no, not remove filters, but we can also like, remove existing filters and replace them only if there's no, what I'm explaining. Just explain with example, right? So we can also write with the keep filters that is not replaced, but this filter is kept, right? And then the other filter is added with and. That means here we're looking for a filter A, right? And then we're asking for, and the filter needs also be A. Yeah, of course, this is possible. Here the filter is already B, and I'm asking for rows where the product description is B and also A. There is no product with a product description B and A, and that's why the result is then empty. And this is something what I meant previously when I say that we can, as a DAX author, we have control over filters. Because if you remove all the other columns, all the other measures here, then only product A will be shown in my table. The other products will not be shown. So this is how I can create a list of like only the 5 products or this or that. So I can write conditions and only return something for example, products which fulfill this condition, and only those are then shown in my table or in my bar chart or whatever. The sum of averages is not the same as the average of sums. Yes, that's also a very good comment. Maybe I want to steal this for my next talk. And you can also remove filters. So calculate not only can change existing filters, but they can also remove the filter. And if I remove the filter on the product description, this means that if I remove this filter, then I get what the total shows, because the difference between the single lines and the total is only that in total there's no filter on the product description. As you just have seen, it's not just the sum of things. It's just the difference is just that there's no filter on the product description. And then again, I see the 670 in all the lines. Again, this is not very useful as we see it here, but with this, we can calculate what is the sales amount of the product A compared to the total. So the percentage, sales amount, the percentage of the total. I divide the sales amount by calculate sales amount all product description. And there's also all selected, which most probably is the one you want to choose for most of the things, but I'm just running out of time. 1 minute to go, and there's one other thing I need to tell you, that there's a huge difference between calculated columns and measures. And the earlier you accept this, the easier it is, and I put everything in a cheat sheet here. So calculated columns increases your refresh time and your model size. Measures do not. It's just a formula which is stored, but not the result. As this is the case, you should only put calculated column, even if you put them, only put them on small tables. Don't put them in fact tables, your huge tables. That's really expensive. Use the measures. They are on the big tables, but of course also on the small tables. You can use them anywhere. The formula in the calculated column is evaluated when you do the refresh. At refresh time, there is no filter. There is no visual, right? There's no user interacting with the data model. So the formula is not filtered at all. If you put a sum there, for example, it's the sum over the whole table. In measures, it's different. The measures first calculated at time when the visual is shown, and therefore those filters are respected. The formula for the calculated column depend on the hosting table. Measure, I did already show you that you can move this around. Chayo, maybe I unmute you. Sorry. The calculated columns can directly reference other columns without having any aggregation. In measures, we cannot do this because there could be several values be available. Even if you're sure there's only one row in the table, DAX asks you to put the aggregation there, just in case. In calculated columns, as they use up space, you should not keep the intermediate results with measures. This is not a problem at all. And calculated columns have something like called an implicit measure over the summarization. And the real measures we call explicit measures sometimes to distinguish them from these implicit measures. So, very fast talking. Any energy and think for questions. Can we use, there's one question here from Daniel again. Can we use DAX to calculate the difference of time between different rows in a date column? Of course we can. If I have time, Miguel, you tell me.
Yes, we have time. Let's answer some questions. So feel free to put them on the chat, or just turn on your mic to ask some questions to Markus. And please continue with this explanation, Markus.
Mm-hmm. So this is, for example, I can have, let's do that as a calculated column again, because I think it's easier here. And we could have, for example, a column which is today, and this is just a today function, right? So we have two different dates. I get the 1st of February, and then I get today, which is the 20th. Can you read this? I think I can increase the formula up there. Let's move it like this. So something like this, right? So we see now the different dates here, and we have like today, which is the result of this expression. And then we can calculate differences, of course. So I can have another column and ask for age of row, which would be today, like the today column, not the function, the today column. And I just subtract the date column from it. Because this works because behind the scenes, so where's the sales? Behind the scenes, in every database, and Power BI is no difference here, in every database, a date is stored as a number. A date is never ever stored in a certain format. So many people I talk to, they believe like if I put it in this format, the database stores in the no, it's converted to a decimal number. This decimal number is usually days since like 1st of January 1970 for many of Unix systems. In Power BI, it's days since the 31st of December 1899. And if I have 5 minutes, I can explain you why it's not 1st of January. There's a fun story to that. So it's already a number, right? So we can subtract things. And if I also tell it's not a date time, but it should be whole number, it will show me that what's the differences in day, for example. Yeah. So between this day and the other day, it's 265 days in between, right? So, and you can also have like there's a date different function where you can also calculate like the differences in different, not only in days, but in hours, something like this. Does this answer your question, Daniel? In the meantime, I take the other question.
Yes.
Okay. Thank you. Unknown user. So if you want to view a box plot visualization, is it necessary to use column creation instead of measures correctly? I don't think so. So the type of the visualization has no implication on what you're doing to the data model. So no matter what kind of maybe I'm wrong here. It could be some of the of these extra visualizations, of these custom visualizations, maybe referring to those. Some of them ask you explicitly for a column instead of it, which is like bad behavior. I hope this is this one. I could not find another one. Let's try this out and edit. Let's see. So maybe this is what your question is referring to. Here's the box plot. And if I put things in here and I try to use, for example, my measure, self-measure data and accept a measure. Okay, but it could be that like in an earlier version of this box plot or a different other box plot visualization did not allow you to use measures. So sometimes this is the case for this custom visualization. For the standard visualization, this is never the case, but I also experienced this that sometimes a measure is not allowed here, which is a bad thing because it can make things more complicated because maybe you need a measure, right? Because you're calculating the marginal percentage, which we can only calculate with a measure because the result of the column will be wrong and rubbish. Hope this did answer your question, Mr. Unknown User. Other questions? Yeah, you're welcome.
Not sure if there is any other questions, but first of all, I think we need to put an idea for that model view that you created, because it would be great for us on the model view to have not only the relationships, but also a small sample of the data. Maybe it would be easier for people to see some of the relationships that we have, right? Because we are only by name, so a great use of the visualization. On second, I think that looking into what I've learned during these years and what I also try to teach on the trainings I do, I always refer back to this that you are saying. So the question about the margin percentages is so it's the one that we have. So as someone was saying in the chat, or the sum of products is not equal to the product of sums, and also the sum of averages is not the average of the sums. So
exactly.
And on percentages, this is completely true. Most of the time people use the Excel version. They say, oh, I just do an average. No, it's not the same thing. You need to think in a different way. That is also a good thing to have. So I think overall, we need to understand what is our context, right? And then use one or the other. But I have a question, a more broader question. So if you have any advice to people that are starting in DAX, so what are their go-to in terms of what they should start to read? And besides these 5, do you have anything else to add? Another tip that you say to people, okay, you also need to know this, okay?
Basically, this 60 minutes is the quintessence of everything. If you really understand what I talked right in the 60 minutes, you're prepared to time intelligence, you're prepared to really complex things because they're based on the calculate functions, and they're based on that to understand that a mesh has this filter context. So basically, it hooks into the past 60 minutes. Yeah, if you need if you want to read and learn more about DAX, of course, there's plenty of books out there. I started learning DAX with this definitive guide of DAX from Alberto Russo and Marco Russo and Alberto Ferrari. Sorry for mixing up the surnames. Currently, I would not recommend this as a beginner, and it's not a beginner's book, right? It's a definitive guide to DAX. When I first heard about it, and I knew both of them, I thought, I mean, this is like a little bit like the nose high up, right? How can anybody write a definitive guide to something? But they achieved it, right? It's a definitive guide, but it's really hard for beginners. And I read it 3 times, and I will read it the 4th time. And every time I read it, I learn a different aspect again. So what I currently recommend for beginners, especially if you're coming from the Excel side, there is this book from Matt Ellington called Supercharged DAX. It's really easy to read. So he has a really funny style and he has cool examples. He even asks you, don't just read what I tell you, really try out this, because if you want to learn it, you need to write DAX, you need to try out things. So this is what I would start with. And as the second option, there's also there's books from Phil Seamark, who's now part of the CAT team, I believe. There's one book he wrote, I think it's Beginner DAX, and there was an advanced book he wrote together with Tom. I'm too silly. Now I don't know Tom's surname anymore. Oh, he's a good friend of mine. So hopefully he does see the recordings.
Tom Martins.
Tom Martins, of course. Oh, it's just a long day.
Thank you, George. Thank you, George, for the. Just for you to know, Jorge Esteves is our Italian guy in Portugal. He knows everything about tax also. So
yeah, okay, yeah. Then maybe also he has some books there. I don't know yet.
No, he doesn't write books. He should. We are always trying to push him to give lectures and books, but he doesn't want to. But he is also very knowledgeable on that.
Mm-hmm. But this is what I would recommend, right? And of course, from SQL BI, which is the company behind Alberto Ferrari and Marco Russo, there's also courses, tutorials. There's also an official Power BI YouTube channel, I think now called Fabric channel, right? Because Power BI is dead, long live Fabric. It's still the same, but some people are scared now with the renaming. There's an official channel from Microsoft, and also if you look up for things there, this is curated, this is good stuff, because what I'm afraid of, or what I see sometimes, is because of the success of Power BI. Of course, there's also a lot of material prepared from many people, and sometimes the quality is not up to where I would hope for. Or what also can happen is that the video is old, and old is 1 year old, can be very old in terms of Power BI, because there's 12 releases. The product changes all the time. There's improvements, and something which is shown as a workaround, as a working thing 1 year ago, you shouldn't do it anymore, because there's a better solution now. So also always look at the date when something was blocked or the video was taken or whatever, because things changing very rapidly, which makes it exciting, but so also sometimes really exhausting, because you always feel oh, there's a long list of things I also need to check out, because another thing was released and there's another cool thing and I didn't have time to check it out. So it can also be exhausting being in the Power BI world.
Yeah, on that last part, I must agree with you. I've been giving answers in the community back since 2016, 17, not really sure. But there was a guy this week answering on one post back then and telling, oh, you can just click a button. I was like, yes, you can, but if you look at the answer, it was back in 2018. At that time, there was no option. So but that's good that people go back and also revisit that information and have those, because it adds value, so that people can know that. So this advanced, and there is a new option. So I don't think we have any other questions. So once again, thank you for your availability and your explanations on DAX. I think that also help for those that are starting, also help to clear some doubts, because everyone is always saying, oh, DAX is very hard, run away from it. No, if we know the concepts, the basic concepts, we are able to make the correct choices. Of course, as in Excel, there is a lot of ways to make calculations, and that's we can. You were talking about VLOOKUP, but there are at least 3 other ways to do VLOOKUPs in Excel. So we have index match, and we have another way that I once saw with a formula that was completely with find and so on. That was completely insane. I was like, okay, another option. So,
okay, yeah.
Yeah. So it's there is always the easy part, the easy one. There is in this case VLOOKUP, and then there are the advanced ones. And in DAX, I think it's the same. Yeah. Sometimes we may show different the same result with different options. Some are more performance than other, but I don't think that we need to use them based on our model. So, and if it works for us, if it gives good results, if it's fast, so why change it? Why should we? But if you learn the learning blocks, that will be good. Okay. Thank you once again. Thank you everyone. So keep aware of our next meetups, and hope you enjoyed this session. Okay. Thank you.
Obrigado.
Thank you, Markus.
Obrigado.
Thank you, Miguel.
Thank you, André.
You guys.
Thank you.
Bye bye.
Thank you, everyone.
Thank you, guys.
Thank you.